numbers and their operations. We can add, subtract, multiply, and divide complex numbers. Today we're going to focus mainly on adding, subtracting, and multiplying complex numbers. So when we add complex numbers, essentially we're going to be identifying, one, is there a symbol here to distribute? When you're adding, most likely that's not going to occur. However, we will still want to add our like terms. So you could rewrite this as -2 plus 7i plus 6 plus 2i. Identify your like terms, so that's 4. And 7 plus 2i is plus 9i. We say that the 4 is the real part and the 9 is the imaginary part. Okay? Again, when we're adding, we want to rewrite it, essentially distributing whatever symbol is in the middle. I know it seems kind of silly right now, but trust me, it will help. So minus 7i. Identify what the common terms are, right? Your like terms. You've got 7 minus 4i, where this is in what we call a plus bi form, where a is 7 and b is -4. Okay, that's your real part plus your imaginary part. When we subtract, that step here becomes important. You want to distribute the negative symbol. So you get -2 plus 7i minus 6 minus 2i. Identify your like terms, so you get -8 plus 5i. Okay, and that's written in what we call a plus bi form. The last one here that we're going to subtract, you want to distribute that negative symbol, so you get 5 plus 3i minus 2 plus 7i. Okay, and you want to identify we are like terms, so we have 3i plus 7i is plus 10i, where a, your real part, and b, your imaginary part, commonly written as a plus bi. Okay, now last thing that we're going to go over today is actually just the multiplying part. So when we multiply these, we want to multiply them as if they were two binomials, just like with variables. Okay, so we want to almost like pretend the x is an I, or the I is an x, until the very last step. So how we do that, we can do it one of two ways. I prefer the box method, where you can draw a box and show the multiplication that way, right? So 7 times 3 is 21. 7 times 5 is 35 with an I. You treat it like a variable. 3 times 2 is 6i, right? Bring the I along. And then here we have 2 times 5, which is 10, and then I squared. And if you remember from Monday, I squared is actually -1. So we can rewrite this. Those two are like terms, and we can add them. So I get 21 plus 41i plus 10i squared. But I squared is actually -1. So this is 21 plus 41i minus 10, or 11, right? 21 minus 10, 11 plus 41i. Okay? And we always want to write them in a plus bi form. Now, last one we're going to go over for today. You can make this very quick. So if you don't necessarily want to use the box method, that's fine. The other way would be to do double distribution, right? 3 times everything in the second one plus 8i times everything in the second. Okay, so it's just another approach than the box method. We have 9 minus 24i plus 24i minus 64i squared. And I notice right away that I have a -24i and a +24i. And those two cancel each other out. So I'm left with 9 minus 64I squared. Well, I squared, that's actually negative 1. So this is actually negative 64 times negative 1, or positive 64. 9 plus 64, I believe, is 73. Now, notice that that does not have an imaginary part, okay? And if you go back to the beginning, right, we've seen these types of pairs before. They're what we call conjugate pairs. Okay, we've seen them often when they're like this. X squared minus 4 is x plus 2, x minus 2. And when we multiply them out, that middle term ends up canceling. And so when we have one that has an I in it, essentially what it does is that middle term is where we end up getting our I values, and they end up canceling each other out. Okay, so today you're going to have a Google form, so good luck, and I will be available Monday, Wednesday, Friday from 10 to 11 a.m. on my live Google chat, and also via Remind, and feel free to email me whenever you need anything. Okay, have a great day.